Okay, welcome back. Here we go again. We don't have much to do here to finish up this section. We're just going to do a quick example of how to find exponential model if you have a couple of points. Then I have a short assignment for you to work on if you want to practice this skill. So in this case, somehow Tia knew ahead of time that the number of emails she sent was growing exponentially. And so the number of emails she sent was growing exponentially? Really? That's what you've come up with? Anyway, so she kept track of the number of emails that she sent, and she found out that in 2000, what does that say? That looks like 2016 on both of them. 2015, she sent 1,000 emails, and in 2016, she sent 1,400 emails. So, in order to come up with an exponential equation for this, all you have to do is figure out the growth rate, which is really easy because we have consecutive years. So if I just divide the number of emails sent in the successive years, so if I go 1,400 divided by 1,000, and yes, that is supposed to be divided by, then I get 1.4. So that means that the amount of emails that Tia is sending is multiplied by 1.4 every year. So then if we take the general form of a quadratic, which is y equals a times b to the x, what we just figured out is that b equals 1.4. So what we can do now is we can substitute that value back in there for b, and then use either one of these points to solve for a. So it doesn't matter to me. Let's take 2015 because 1,000 is an easier number maybe than 1,400. So I'm going to put 1,000 in for the y. A is what I'm trying to find. We figured out that b is 1.4. And I'm raising this to the x power. So this says the number of emails she sent each year since 2009. So what I'm going to use for x is actually going to be 6. Because 2015 is 6 years from 2009. Okay? So then in order to figure out what that is, to solve for a, I need to figure out what 1.4 to the 6th is. So, on my calculator real quick, 1.4 to the 6th power is 7.529536. That's still times a. So a would equal 1,000 divided by that number, 7.529536. So that works out to be, let's see, 1,000 divided by 7.529 whatever is 132.8. Okay, so now that we know what a and b are, it's kind of getting messy here, sorry about that. Then we can write our equation, y equals a, which is 132.8 times 0.4 to the x. So this guy right here is our final answer. Okay. So like I said, that's pretty simple. Here's another one you can try if you want on your own. Pause the video and work your way through that. So the way this would look is, let's see, I'm going to figure out from 1954 to 1955 it went from 35,000 to, I'm sorry, from 31,000 to 35,000. So if I divide those two numbers, that tells me what it's multiplying by every time. So 35,000 divided by 31,000 is 1.129. So if this pattern continues at exactly the same rate, then my multiplier would be 1.129. So now I need to take that and figure out what A is. So I'm going to take y equals A times B to the x, and I'm going to plug some stuff in. Let's see, for y, let's do the second point. So for y, I'm going to go 35,000 equals A times B, which we just figured out is 1.129. And I'm going to raise that to the x power, but in this case this is 1955. We started at 1950, so the exponent is 5. So that means 35,000 equals is 1.129 to the 5th. 1.834, we'll call it A. So that means that A equals 35,000 divided by 1.834, which is 19,083 $97. Okay, so that means my final answer would be y equals A, which we just figured out to be 19,083 97 cents times 1.129 to the x. Okay. So this is our final answer right here. Okay, alright. The only other thing that's in this section is how to do this on a calculator, and I don't really have access to the online calculator on this computer because I'm sitting in my bedroom. It's not hooked up to the internet. So this is something we would just have to skip for now, I guess, but the basic idea is you would just enter this into a table. We've done this with other functions before. So the x's would be the times, so we would go 0, 2, 3.5, 5, and so forth. Hi. Anyway, so we'd have the x's here, and then all the y values here. We put that in the table in Desmos. And then we would do the thing that we've done before where we'd say y1 is approximately equal to a times b to the x1, and the calculadora would tell us what those values are. So that's pretty handy, but we're not going to mess with that. So really that's all we need to worry about. So here's what we learned in this section the general exponential model, y equals a times b to the x. A is what you're starting with, b is what you multiply by every time, and x is the number of years. So here's an example of that. Then how does this apply to compound interest? Changes the formula just a little bit by adding this value of n in there, which is how often interest is compounded every year. And then finally, if you continuously, this is the key word, continuously compound interest, then that changes the formula to this right here with the natural base e. It's actually quite a bit easier than this one to use, okay? All right, so just a handful of problems for you to do if you want to check your understanding. I'll make a video of me going through those answers, which you can watch if you want. All right, I hope you're doing great. Bye.